looking at this one. We know, can we just do the antiderivative as it's written?
No.
No, because it's a product. We have x's in both of them. We don't have a single trig function that has a derivative of secant cubed x tangent x, so that won't work. So we have to pick one for our u. Now I've been telling you that u was the inside function. Here that's a little less obvious unless you think about what this means. It's the integral secant cubed means secant of x to the third. So what's on the inside? What is the derivative of secant? And we put the dx on the end. Now, when you go to rewrite this, we had secant to the third. So if I write that as u to the third, then I run into trouble because all I have left is a tangent x dx, but this one also has a secant with it. When I'm looking at this integral, I need to be able to write it as something times the secant x tangent x. So if I did that, wouldn't that be equivalent to saying secant squared times secant tangent dx? So this portion is my du. This portion would be u to the second. And the reason we had changed that is because I needed one of the secants to be a part of my du.
Why? Because it's a derivative there.
Yep.
Okay.
What is the antiderivative of u squared? Plus c. And then at the end, we just have to replace u. So u was secant, so that would be 1/3 secant cubed u, or sorry, secant cubed x plus c. Or you could say 1/3 and then in parentheses secant x with a cube on the outside. Is that one okay? Okay, so if I look at this one, we can't multiply it out because it's to the fifth. Order of operations says you do the exponent first. U, what's the inside? And then du would be 3 dx. So if I go to write this integral, 3x minus 1 to the fifth would be u to the fifth. So we took care of that x. We have a dx here. So what would I have to do with this one? So this is the same as saying 1/3 du is equal to dx. So we have a 1/3 du. But have I taken care of everything? No. We still have an x out here. We have to replace all of our x's. That x was not a part of my du. Are there any other options for that? Can you think of any way I could figure out what x is equal to? Well, what if I take my u? Can we solve for the x here? So if we add the 1, divide by 3, could I just write that as a 1/3 times u plus 1. So my x, it wasn't a part of the du, so I had to go back to my u and rework that. So the x is 1/3 times u plus 1. Okay, my integral is all jumbled here, so let's fix it. 1/3 times 1/3 would be 1/9 u to the 5th times u plus 1 du. Okay, initially this doesn't really look all that much different. We still have something to the 5th. We still have another term. However, it is because now, can you multiply those? It's just the u to the 5th power. Can you take u to the 5th times u and u to the 5th times 1? The 1/9 you could distribute. I'm just going to pull it out in front of my integral. So that would be a 1/9 in front, and then this is u to the 6th plus u to the 5th du. Antiderivative of u to the 6th plus antiderivative of u to the 5th. Let's see. So in the end, if we wanted, we could distribute. This is 1/63. U was 3x minus 1 to the 7th plus 1/54 times 3x minus 1 to the 6th plus c. Alright. That one was definitely a little more challenging, so we will have to do some more along those lines. Are there any questions so far?
On example 7, I'm I don't know what to ask. Like, where did our du go? Like, why don't we multiply the whole thing by secant x tangent x dx?
Okay, so we took the original and we rewrote it. We said, well, we know the du is secant x tangent. So I took one of my secants away because we had 3 of them. So I wrote it as a secant squared times secant tangent. Well, the secant tangent, this became the du. Secant was my u, so that's where the u squared came in. Did that answer your question?
Mm-hmm.
Other questions? So I want to keep practicing this, but I want to start doing some with definite integrals. And there's really 2 different options for the definite integrals. If the first option is that we work it out, we work this out, we change it back to x's at the end, and then we plug in our limits. And we know if we have numbers to plug in, we don't have to have the plus c, so you could do the normal substitution, just at the very end go back to x and plug in your new limits, or your limits. The other option is if you don't want to have to change back to x, you can change your limits at the beginning. So basically, if we know our x's, we can plug those into the u formula and get the limits for the u. And then at the end, we don't have to ever go back into x. I don't really care which way you do it, so I want to just kind of show you both options and see which one you guys prefer. So if I look at this one, we're going to treat it as we have been doing all these others to start with. We have integral from 3 to 5. You could rewrite this. This would be like 30 minus x squared to the -2 and the dx on the end. So what is my u? So du, derivative of 30 is 0, so that goes away, minus derivative of x squared would be negative 2x, and that gets a dx. So if I'm looking at this, we had 30 minus x squared to the negative 2, so this becomes my u. We have an x and a dx. So if I just want those, what do we have to do? So negative 1/2 du would take the place of the x and the dx. So we get negative 1/2 u squared du. Alright, so the two options I was mentioning. We can keep the 3 and the 5. But you have to remember then, those are x values. And so when you get done with integrating, you have to go back, replace your u with 30 minus x squared before you plug in the 3 and the 5. I see a lot of problems when people do it that way. They just forget that those are their x's and they plug them in the wrong spot. The other option is to think, okay, if x is 3, if you plug a 3 in here, so 30 minus 3 squared would be 30 minus 9, which is 21. So when the x is 3, my u is 21. If x is 5, so 30 minus 5 squared, so 30 minus 25 is 5. So when x is 5, my u is 5. So we could go ahead and change those numbers now. Then those are u values, so do I ever have to put my x back in? No. So now it's just a normal integration problem. So this is a little bit faster. You just plug in those numbers at the beginning and then everything is in terms of one variable. So what is the antiderivative of negative 1/2 u to the negative 2? We add 1 to the power, we get negative 1. Reciprocal in front, so it would be 1/2 u to the negative 1. Because I changed my limits, I can now just evaluate from 21 to 5. So if I put in my 5, 5 to the negative 1 is 1/5. Minus, if I put in my 21, 21 to the negative 1 is 1/21. And so we can work that out. Common denominator. So 5 times 21 is 102. This one gets a 5 on top and bottom. Minus 5 is 16 over 102. Times a half would be 8 over 102. Sorry, not 102, 105. 21 times 5 is 105. Are you guys okay with me going ahead and changing my limits so that I don't have to go back to x's at the end? And I'm probably going to stick with this method. So now we're just practicing. Number 10. Okay. If I am looking at this one, can you guys tell what the inside function would be? Sine 2t, because that's the one with the exponent. So my u would be sine 2t. du. Derivative of sine is cosine, angle stays the same, times derivative of the inside, derivative of 2t is 2, dt. So my sine cubed 2t would turn into u cubed. I need a cosine 2t dt, so I don't need the 2, so we'll just divide it over. cosine 2t dt is my 1/2 du. And then we can change our limits. If you put in a 0, 2 times 0 is 0. What is the sign of 0? 0. If I put in pi over 4, 2 times pi over 4 is pi over 2. So it's like 90. Sine of 90, radical 4 over 2, which is 1. So now antiderivative, if we add 1 to the power, would be 4. So reciprocal in front, 1/2 times 1/4 would be 1/8. 1, 0, 1. 1 to the 4th is 1, 0 to the 4th is 0, and 1/8 times 1 is 1. Is that okay? 3 more. What's my u? Derivative of u is 1 dx. So, the x plus 5 becomes my u, so I have a square root of u, or I could write that as u to the 1/2. Dx just becomes my du, but we have a problem. There is still an x in front. What do we have to do? We have to use our u to find out what x is. So u minus 5 equals x, so I'm going to replace my x with u minus 5. Okay, I change my limits. I put in a -4. -4 plus 5 is 1. The upper limit is +4. So 4 plus 5 is 9. What do we have to do before we work out the antiderivative? So u times u to the 1/2, add exponents, so that would be 3/2. 5 times u to the 1/2 is 5u to the 1/2. du. Add 1 to the power, 3/2 plus 1. So 3 over 2 plus 2 over 2 is 5 over 2. Reciprocal in front. Minus 1/2 plus 1, so 1 over 2 plus 2 over 2 is 3 over 2. Reciprocal in front. Oh, thank you. 5 times 2 would be 10 over 3. Okay, now we evaluate. So we have 2/5. This one's not going to be beautiful. 9 to the 5/2 means the square root of 9, which is 3, to the 5th, which would be 243, minus 10/3. 9 to the 3/2, so square root of 9 is 3, cubed is 27. Minus, if you put in a 1, you get 2/5 minus 10/3. So feel free to jump in and help on that. For the sake of time, let's just plug it in. We could work it out and get our common denominator if we needed to, but What do we get? 152 over 50. Any questions on that one? Looking at this one, what is our u? So our variable is t, so u should be something with a t in it. Cosine t, because that's the exponent, so that's like our inside. Du, derivative of cosine is sine t dt. We don't need the negative, so we can divide that over. So we get the integral of e to the u times a negative du, so negative e to the u du. What's the antiderivative of negative e to the u? We don't have limits, so this one we have to have the plus c. And since I don't have numbers to plug in, we have to replace the u. So it would be negative e to the cosine t plus c. And the last one. So this looks like it has multiple variables. It has a's, it has x's. When you look at the end, dx tells me x is what we're treating as our variable. So a is just going to represent a constant here. We don't have two variables at once. We have one variable. Any other letters are just representing constants. So what is our inside? So du, if a is a constant, the derivative of a squared is 0 minus 2x dx. So I need the x and the dx. I don't need the negative 2. So I'll divide that over. So we have the square root of u, or u to the 1/2, times a negative 1/2 du. And we can change our limits. If we plug in a 0, which variable is it going in for? X. So if I put in a 0, we get a squared minus 0 squared, so a squared. If I put in a 9, I get a squared minus 9 squared, so that's a squared minus 81. All right, not beautiful limits, but let's work with it. Antiderivative, add 1 to the power, so 1 over 2 plus 2 over 2 would be 3 over 2. You need a 2/3 in front, times a negative 1/2 would be a negative 1/3. So the negative 1/3 we could pull out in front. And then just have a squared minus 81 to the 3/2 minus a squared to the 3/2. Since we don't know what a is, there's not a whole lot we could do. Really, the only thing I would suggest, if you have a squared to the 3/2, what does that become? The 2 times 3/2 is just 3. And that would be our final answer. Okay, so we are at the end of this section. Yesterday, I told you you could start the homework, the 3 through 39, every other odd. So today, we can finish the rest. So here's the game plan. Tomorrow, I'm not moving on. We're going to practice this some more. So we're going to have an activity in class to practice this. And then I'm going to give you, like, I don't know, maybe 8 problems, no more than 8. will agree to that. So I'm going to give you a handout with a few practice problems tomorrow as well. And then all of it, the book problems and that handout will be due on Monday. Okay, so this isn't due until Monday. However, tomorrow is not just a whole day to work on it. We're going to do an activity, and then you'll have a few more problems, and then whatever time you have left, you can work on it. Or not Monday, Tuesday, because we're not